In this video, we will discuss chemistry or SAR of sulfonyl urea class of oral hypoglycemic agent. Now, as far as the sulfonyl urea anti-diabetic is concerned, name indicates what kind of moiety they do contain in their structure. These agents are known to contain sulfonamide moiety in their structure, and therefore they are called as uh, sulfonamide structural analogs. So their structure is similar to the sulfonamide moiety. And as far as the sulfonamide is concerned, these agents were known for their antibacterial activity. And surprisingly, sulfonyl ureas and class of antidiabetic, these agents, I will list names of these agents in a few minutes. But these sulfonyl urea antidiabetic agent, they do not possess any antibacterial activity. They do possess only antidiabetic activity. As far as the classification is concerned, sulfonyl urea class of agents, they are further classified into two: first generation agents and second generation agents based upon their effectiveness. Second generation agents, namely glipizide, glibenclamide, glimepiride and gliclazide, these agents are more useful and more potential anti-diabetic agent, and they do possess fewer side effects as compared to the first generation agents, namely acetohexamide, tolbutamide and chlorpropamide. But whether it is first generation or second generation, these agents are known for undesired effect, that is weight gain for the patient who is taking these drugs for a long period of time. Now we'll discuss SAR of sulfonyl urea agent. SAR means structure activity relationship. Here we will discuss what will be the profile of the compound, or what will be the change occur in the activity of a compound if we modify even a small portion of that molecule. So if you observe sulfonamide, sulfonyl urea agent, they do possess sulfonamide portion. I will call it as the aromatic portion, and on another end, aliphatic portion is there. And on aromatic ring again, substitution pattern is there. So here, whatever basic skeleton is there, which is useful as a anti-diabetic for anti-diabetic activity. But even if we go on modifying R and R dash, that is portion or substituent present on aromatic ring, or if you try to modify aliphatic or R dash, that results into change in the activity and even undesired effects or side effects. So what modifications are suggested, we'll discuss one after another. Very first is benzene ring should contain one substituent preferentially at para position. So presence of substituent at para position is essential for the activity, anti-diabetic activity, and this kind of analogs or this kinds of compound will possess good anti-diabetic activity as compared to the analogs which will not have substitution at para position of the aromatic ring. Then next part is substituent like methyl, acetyl, amino and chlorobromine and CF3 present on the benzene ring if they results into active compound. So whatever substitutions mentioned over here, these substituent, if they are present at the para position of the benzene ring, they produce or resultant compound will be good anti-diabetic agent. Now aliphatic portion R dash, this portion imparts the lipophilicity to the compound. That is, it is responsible for the lipophilicity of the compound. It gives the lipophilic characteristic to the drug molecule. So we can modify R dash, that is we can increase number of carbon, but we cannot increase number of carbon the way we want. Optimal activity will be there if number of carbon will be there between 3 to 6. So not less than 3 carbon and not more than 6 carbon must be there in the as a part of R dash. Otherwise compound will not have activity. Examples are there: that is acetohexamide is there, chlorpropamide is there, and tolbutamide is there. Now if you compare the structures of these agent, you will understand why these names are given. Acetohexamide, so acyl group is there. To designate that, name is given aceto, and here to designate this ring, hexa portion name is given. And therefore, so in order to memorize the name of a compound, you have to understand acetohexamide means this portion uh, speaks about the nature of substituent and aromatic ring, and this portion speaks about the nature of R dash. So this name gives idea about the nature of R and R dash. Next drug, that is tolbutamide. Again, it is very clear. Name indicates nature of R and R dash, that is substituent on aromatic ring and aliphatic side chain. So toluene is there. So to designate that, TOL, and 4 carbon chain is there. So to designate that, but suffix is there. So tolbutamide. Next is chlorpropamide. Again, same analogy we have to use while understanding or while memorizing the structure of a drug. That is, chlorine is there and propyl is there at another end. So R dash is maybe if it is methyl and ethyl. If it is there, then these analogues will be inactive. That's what I already made mention. R dash must be there between 3 to 6 carbon. Activity lost if R dash is more than 6 carbon also. So we cannot have a chain having carbon more than 6 and less than 3. Now something about tolbutamide. As far as the IUPAC name is concerned, 1-butyl 3-para-toluene sulphonyl urea. So 1-butyl means now name is given based upon the consideration to the urea at one position. So this nitrogen it is been designated as 1. So at 1 butyl is there, at third para-toluene sulphonyl is there, and last urea. So this is how we can give name. Sodium salt of tolbutamide is water soluble and therefore used intravenously for diagnosis of mild diabetes mellitus and functioning of the pancreatic islet cell of adenomas. So this is another application of tolbutamide apart from its anti-diabetic use. It is also used in diagnosing whether the person is suffering of diabetes or not. We'll discuss how when we'll study the mechanism of this agent. The sterile dry powder of tolbutamide is dissolved in sterile water for injection to make the clear solution, which then should be administered within 1 hour after its preparation. Now, as far as the continuation of SAR is concerned, aryl group R generally give toxic compound. But try to understand, even though aryl group is known for producing toxicity, this is also required as a part of a anti-diabetic agent. This part is essential for the activity also. R group on the aromatic ring primarily influence the duration of action of the compound. Now substituent, para substituents precisely present on the aromatic ring, this is responsible for duration of action of the compound, means how much long the compound will act. Compound with para beta aryl carboxamide ethyl substituent result into more active or more potent compounds, that is glipizide. That is, we are talking about modification of para substitution of aromatic ring. If we have substitution in the form beta aryl, we are not defining nature of aryl. Beta aryl carboxamido ethyl. So this portion I am talking about. In general, aryl. So carboxamido ethyl portion is there. So In second generation sulfonyl urea, this moiety is present. So whatever modified analogs are there, you will find they do contain this part as a modification at aromatic portion of sulfonyl urea. So first drug, that is glipizide, you will be able to see beta aryl. So this portion I will treat it as aryl now. Beta aryl carboxamida ethyl portion is become attached to our first generation sulfonyl urea compound, and the rest of the portion is same. So now what it has been become linked, this portion. So in second generation we have to understand this part will be common at R, and based upon nature of terminal ring different compounds are there. So one compound, that is glipizide, it do contain methyl pyrazine carboxamidoethyl phenyl sulfonyl urea. So when you try to memorize glipizide, you have to remember this portion. As we already learned, this portion is already there in second generation, and in addition to that, methyl pyrazine is there. This is how you can memorize. Second drug is there in the class, that is second generation, that is glyburide. Here aryl portion has become modified in the manner that is 2,5 chloroortho anisomado ethyl phenyl sulfonyl 3 cyclohexyl urea. Now last portion from the sulfonyl urea class of the drug is uh, in your syllabus synthesis of drugs. It has been mentioned, and synthesis of only those drugs on front of whom asterisk is there. So if you go through syllabus, they are expecting synthesis of tolbutamide. So now structure is there in front of you. Tolbutamide, already told you how to memorize structure. Toluene portion is there, and nature of alkyl is, that is but, that is chain having 4 carbon at terminal end. Now they are expecting from you to write schemes of reaction depicting synthesis of tolbutamide. Now it is not necessary you will follow the same steps of reaction which I am giving you. Even if any you came across any alternative reaction pathway for synthesis of tolbutamide, provided it is correct, you can write it. At the same time, those who are going to appear for competitive exam like GPAT, you will find some questions on the synthesis. They will ask you starting material or intermediate for the synthesis of a drug, and precisely they will not tell you they will not make mention about the structure of a drug. They will only simply ask you what is. They will provide 4 options. One among the following is a raw material or starting material in the synthesis of tolbutamide. Now, to synthesis in general is easy if you think rationally about the structure. Now, in this case, if you focus on this portion, if you try to cut here, if you try to cut here, if you try to cut here, you will understand these are the compounds which are available, and so we can start synthesis from these compounds only. Now, toluene is frequently available, well available, and if we perform electrophilic aromatic substitution reaction, we know methyl group is electron releasing substituent, so para directing effect will be there, and you will get this compound easily. Now we required chlorine for some specific purpose, as chlorine is electronegative substituent, it is good leaving agent, and when leaving group is there, that will increase the rate of reaction. So if we treat octane compound with ammonia very just by stirring in very fast manner, we will get this compound, that is para toluene sulfonamide. So what happen, this chlorine will make sulfur electron deficient. In addition to that, 2 oxygens are there. So lone pair of electron present on the nitrogen, it will become coordinated with sulfur, and in the next step chlorine will become depart, and you will get this structure. Now it is not expected from you to write mechanism of these reactions as far as the synthesis is concerned. Now you will be able to observe part of the molecule we have obtained now. Now what it has been left is this portion, it is still missing, and we have to incorporate the rest of the portion, but somehow we don't have this portion available directly, so we have to perform some other reactions to obtain that. So if we treat this intermediate with ethyl chloroformate in the presence of pyridine, of course pyridine act as a weak base, and that is always required when reaction involve loss of HCl, so that what will happen, it will absorb HCl and pyridine hydrochloride will form, which will be removed by washing with water. So now same reaction will be there. Chlorine, a living agent, is there, and it will make this carbon further electron deficient in addition to oxygen. So oxygen and chlorine, they are there, which makes this carbon highly electron deficient, and lone pair of electron is there on the nitrogen. So somehow this lone pair of electron will become coordinated with carbon, so that new bond will form, and in the next step chlorine, which is a living agent, which will depart along with pair of bonding pair of electron. Now we got this intermediate, that is N-para-toluene sulphonyl carbamate. We know this portion we don't want in this form, but somehow depending upon the availability of chemical, we obtain this compound. We don't have a compound where we will obtain directly butyl portion over here. Now when we treat this with butyl amine, that is name of reaction will be ammonilysis, and solvent will be ethylene glycol, will get straight away tolbutamide as a compound. Now you observe carefully over here, we know esters are susceptible for hydrolysis even when we add water, because this carbon is electron deficient, and lone pair of electron present on O of OH will become coordinated over here. So similarly, lone pair of electron present on the nitrogen will become coordinated over here. A new bond will form between this carbon and nitrogen, and in the next step, because of unstable intermediate, this ethoxy group will become depart, and we will get our desired compound, that is tolbutamide. That's all. Now we'll see last portion of sulfonylurea, that is its mode of action. Means we will learn how sulfonylurea produce their anti-diabetic action. We already discussed these agents are known for insulin secretagogue, that is they produce the secretion of insulin, and they bind at a specific receptors, and these receptors are therefore known as sulfonylurea receptor. So sulfonylurea are widely used to treat non-insulin dependent diabetes mellitus. These are insulin secretagogue. They trigger the insulin secretion by the closing of ATP sensitive potassium channel of the pancreatic beta cells. So they act on the ATP sensitive channel present on the pancreatic beta cells. So this closure of ATP sensitive potassium channel in the beta cells, it results into initiation of certain chains of biochemical events, and these events eventually will result into release of insulin. Now specific structure moiety present in the sulfonylurea, that is the sulfonylurea analogs, they they bind to particularly at beta cell present, that is at ATP sensitive potassium channel, and it exhibit two portions, that is a pore, that is a pinhole like portion, pore or channel we can say, pore forming subunit, it is known as KIR 6.2 unit, and a drug binding subunit, that is SUR1, that is name has been given after understanding its binding position, that is sulfonylurea receptor 1, and which function as a receptor for the sulfonylurea drug. So all the drugs, whether it is first generation or second generation, they do bind at SUR1 and they produce release of insulin. That's all. This is all about sulfonylurea class of agent.